Assalamualaikum students, hope you people are doing good by grace of Almighty Allah. Last time we were talking about law of conservation of mass. I told you people we have to discuss two important laws. Those particular laws are called as laws of chemical combination. In laws of chemical combination, we discussed one law in the previous video lecture, that is law of conservation of mass, and I gave you some examples regarding this law of conservation of mass. And now in this video lecture we are going to discuss some more important I can say examples of this law of conservation of mass to make you people understand what actually this law of conservation of mass is. Last time I told you people that this law of conservation of mass, I can say, deals with the relation between mass of reactants and products during the chemical change, and it was stated by a French chemist. I told you people that French chemist is also known as father of chemistry, Anton van Leeuwenhoek, in 1774. According to the Anton van Leeuwenhoek, he told in his statement that during any chemical change, the total mass of the reactants is equal to the total mass of the products. In other words, this law is also called as law of conservation of mass, because in this law mass can, this is mass can neither be created nor destroyed, but can simply change from one form to another. Let me quote a previous example before you people. This is carbon plus oxygen gives carbon dioxide. This carbon is having atomic number of 6. We have to consider, I told you people, an element is having mass because of neutrons plus protons, or neutron number is always equal to the proton number. So atomic number of carbon is 6, that is 6 plus 6, 6 protons, 6 neutrons. And oxygen is having atomic number of 8, that's 8 protons plus 8 neutrons into 2 equal to carbon dioxide. It was coming out 44, that is 6 plus 6 12, plus 8 plus 8 16 into 2, that is 32 equal to 44. So mass of the reactants, these are reactants. Starting material, I told you people are called as reactants, and I can say the last product, the last materials I can say called as, which is formed after the reaction. When the two reactants come close with each other, they form the product, and this is product carbon dioxide. In this reaction, that and the mass of the carbon dioxide comes out to be 44 gram, and 44 gram from reactant side and 44 gram from product side. That is LHS equal to RHS. That means left hand side is equal to the right hand side. That means mass remains conserved. And I told you people that this law is also called as law of indestructibility of the matter. So from this conclusion, we draw actually from this discussion we draw a conclusion that mass of reactants is always equal to the mass of the products. In other words, this law states that mass can neither be created nor be destroyed, but can simply change from one form to another. And this was the law of conservation of mass. Let's discuss some more examples to make you people clear regarding this law of conservation of mass. Let's move forward. Let's discuss some more examples. So let's discuss one more example as far as this law of conservation of mass is concerned. I told you people that mass of the reactant should equal to the mass of the product, that is LHS should equal to the RHS. Left hand side should equal to the right hand side. So as far as this methane is concerned, whenever methane reacts with oxygen, this is methane in reaction with oxygen, methane CH4, this is CH4. Carbon is having atomic number of 6, that's 6 neutrons plus 6 protons, that's 12, plus 4 1R, because hydrogen is having atomic number of 1, that is, here is 4 times oxygen, 4 hydrogen atoms, that is 4 into 1 equal 12, plus 4 into 1 4, that equal to 16, that's this 16, that's this 16. Now let's come to the oxygen. This is 2 times oxygen, 2 times oxygen, 2 times oxygen. 2 into oxygen is having atomic number of 8. That is 8 neutrons, 8 protons. That's 16 into 2. That equal 2 into 16 into 32. 32 into 2, that's equal to 64. That's this 64. 2 into 32 equal to 64. That is, mass of the reactants is, whenever there is a reaction between methane plus oxygen, mass of the reactants is equal to 16 plus 64. 16 plus 64, that's 80 grams. So mass of the reactants is 80 grams. That's mass of methane plus oxygen is equal to 80 grams. I told you people, mass of the reactant should equal to the mass of the product. These two are reactants and these are the products. Let's discuss the mass of the products. Carbon dioxide. Whenever there is a reaction between methane and oxygen, there is a formation of a carbon dioxide gas. This is CO2. Carbon is having atomic number of 6. That's 6 neutrons plus 6 protons. That's 12. Plus oxygen is having atomic number of 8. That's 8 neutrons, 8 protons. That's 16 into 2. That is 12 plus 32 equal to 44 grams. Look, this is 44 grams. Mass of carbon dioxide is 44 grams. Now another product, that is water. That's twice water. This 2 is multiple of these hydrogens as well as this oxygen. 2 are 4. That is 4 oxygen plus 2 times oxygen. That is 16 into 2. That's equal to 4 plus 32. That is equal to 36. So the second, as far as water is concerned, the mass of twice water molecule is 36. So the gross total of these carbon dioxide plus oxygen twice water is 44 plus 36. That is equal to 80 grams. So mass of the reactants equal to products, that is 80 grams equal to the 80 grams. So this equation or this reaction follows the law of conservation of mass. That is, mass of the reactants is equal to the mass of the products. This law, that means LHS equal to RHS, and this is the validity of the law of conservation of mass. So according to the law of conservation of mass, the mass can neither be created nor destroyed during a chemical combination or in a chemical change, but can simply change from one form to another form. This another first form, this is methane plus oxygen. Whenever there is a reaction between methane and oxygen, there is a formation of a carbon dioxide gas, and whenever there is a formation of a carbon dioxide gas with carbon dioxide gas, there is evolution or there is a formation of a water molecule, and the gross total of the atomic mass is equal to the mass of the reactants is equal to the mass of the products. From this discussion and from this, I can say, discussion, we came to know that mass of the products is equal to the mass of the reactant. That's mass remains conserved. So from this discussion, we came to know that the law of conservation of mass states, or it gives a relationship between the mass of the reactants and the mass of the products during the chemical changes. So mass of, this is carbon plus oxygen equal to carbon dioxide. We discussed this very reaction, and we discussed CH4 plus twice oxygen gives carbon dioxide plus twice water. So in these two reactions, mass of the reactants was coming out to the mass of the products. So according to the law of conservation of mass, mass can neither be created nor destroyed, but can simply change from one form to another form. So now I will give you one more example as far as this law of conservation of mass is concerned. This is sulfur plus iron gives iron sulfide. Whenever there is a reaction between sulfur and iron, there is a formation of a iron sulfide, and mass of sulfur is equal to 32, mass of iron is equal to 56. That is actually the mass of the iron is equal to 55.845. That's approximately equal to the 56. And whenever there is a reaction between iron and sulfur, there is formation of iron sulfide, and it has been experimentally proved that mass of the iron sulfide was coming out to be 88 grams. 32 plus 56, 88. So mass of reactants was coming out to be the mass of the product. So from this discussion we came to know that mass of the reactants is equal to the mass of products, and this law actually gives the relationship between the mass of the reactants and products, and according to this law, mass of the reactants is always equal to the mass of the product. So thank you for watching this, and I hope that you people have enjoyed this very important concept as far as atoms and molecules are concerned, and you are requested to this, I can say, at your homes, respective homes, do try at least 10 reactions in which mass of the product should come equal to the mass of the reactants, or the mass of the reactants should come equal to the mass of the products. Do discuss, or I can say do try at least 10 more reactions at your homes. This is, I can say, assignment for you people. Thank you for watching this. Inshallah, in the next video lecture we are going to discuss one more law which govern the law of chemical combination, that's law of constant proportion. Till then, Allah Hafiz, stay safe and stay blessed.